Alright, this video is all about points of equipotential, places where the voltage is the same. So a couple things that I just want to refresh on is from previous videos. The voltage is the work per unit charge, or we could always say that the voltage is equal to the electric field times the distance between the two plates or between the two charges itself. Okay, so with that in mind, I want to write out a few equations and do a little substituting. So this is really going to be the electric potential due to a point charge. So if I have just a charge at some spot, we want to find out what is the value of the voltage at certain distances away. Okay, so how about here? How about further away? How about further away? And then that's going to sweep out an area. Okay, so if I write a few equations, like the electric field is equal to the force over the charge, I could also write that the electric field is the voltage over the distance, or I could treat that as, instead of distance, as a radius. Okay, and then the last one would be the force is equal to kQq over r squared. So this is our Coulomb's law. Okay, so I've led you through the steps here. So this again is the electric potential due to a point charge, the voltage away from a particular charge. So for letter A, it says first sub F3, so this force 3 into 1. Now we've done this a few times so that we can write an expression for the electric field without the force in there, because here we've got the force, we want it out. So E is kq over r squared. For part B here, then I'm going to substitute in this electric field, which is V over R. I'm going to substitute that in to this equation. So instead of having E in there, I'm going to put in V over R. So V over R equals kq over r squared. And then it simply comes down to reducing. And I end up with an equation that says the voltage due to any point charge is equal to k times the charge over the radius. Okay. So what exactly is this good for, I guess? Okay. It's good for finding points of equipotential. And it's really, I think it's fairly obvious here. As long as the radius stays the same and the charge stays the same, then the voltage will be the same at that particular radius. So a little visual of it is if I have a charge, okay, I've got some field lines that lead off, and then for every radius, if I took out, like if I had a compass and I went to here and made a circle around, okay, every point on this dashed line that I've made would represent the same voltage, and every point on this line would represent the same voltage, so on and so forth. Okay, so this particular drawing shows you field lines that move directly away from the charge, and then equipotential lines that are perpendicular to that electric field. Okay, so all those points represent points of equipotential.